Welcome. I'm going to speak about the event NVIDIA delivered today called NVIDIA Quantum Day. And basically, I will touch on some of the key areas that they focus on mainly and the new advances on quantum error correction and calibration. That's something that they talk about, and how also the agentic AI is going to integrate in all this ecosystem. So we will be touching a little bit about the AI factories and the quantum processor units and the INSYN, the new tool for calibration and error correction based on trained AI models, and how that relates to MBQ Link, that was a previous product from them, and the agentic AI, how all these pillars are going to be integrated into their strategy, and you as a user or even as an investor pay focus on depending on how the industry is moving. But basically, those are the pillars I will talk. But before we get into the new technologies NVIDIA presented today, we have to understand that quantum computer hardware has different stages. This is an approximation, of course, but as you can see, we started with early theory. Then, as the time progressed, we went from early theory to experimental quantum computer. Then we have the NISQ area. Then we are reaching right now a point of uh, early fault tolerant systems, and many companies are trying to do a scalable fault tolerant computing. And at some point, the goal is to reach quantum advantage at scale. But of course, there is something called quantum utility. That is, even though we are not in the quantum advantage, we can have utility. And even if it is a factor of one or two in the execution of algorithms. So there are many algorithms that are being pushed on drug design, finance, and optimization based on quantum utility. But this is very important for you to grasp the idea of this chart and see how the industry is moving and which of the states it is. So this niche area, basically the systems are very noisy, they are very fragile. The quantum states are hard to keep. So there is low coherence time, there is pure connectivity, and there is a lot of noise that cause the system not to behave as we should want it to work. So this is the NISQ area. Then we are reaching a point where we have early fully tolerant quantum computers, but error correction is very expensive, right, to do. And of course, you have logical gates, and the hardware stability is very fragile. And just approximation again, for one logical qubit, you'll need around 1,000 to 1 million physical qubits. This is an approach companies are trying to do, like Microsoft, in order to do useful computation, is to wrap these fragile physical qubits into one logical one. Let's imagine like a ball, and inside this ball you can have many physical qubits, and then you arrange them in a way that they can work together and they can fix their errors. They can be stable enough to be considered one logical qubit, and based on multiple logical qubits, then you can start to do computation. Just keep in mind that quantum hardware is analog, it's not a digital machine. So it uses frequencies, microwave pulses, analog control signals. And of course, if you work with this type of systems, you know that you have to do calibration and you have to retune the frequencies, adjust the pulses, reassure, measuring the error rates. And of course, this requires a lot of manual work, and also updating the control parameters of the machine. So this is the previous product NVIDIA had called NVIDIA MBQ Link, and we are going to read together the description. So after that, I'll explain you what that means. So basically, it says the Open NVIDIA NVQLink platform architecture tightly integrates quantum hardware with the state-of-art accelerated computing to power the development of quantum processor units at scale. Using real-time APIs, we need the NVIDIA CUDA software platform. Researchers can easily leverage NVQLink for the low latency, high throughput connections. They need to perform control tasks like calibration and quantum error correction. So basically, this software or this platform enables the companies to have their quantum hardware and they can connect. And then based on that connection, you can do calibration and quantum error correction. But this require more manual work, maybe not that automated as we will see for the new products they offered. But this is the product they have. Now they just announced today something called NVIDIA Insync. Basically, it's a state-of-art quantum computer pre-trained models in order to use this tuning and error correction and calibration of the systems. And based on what NVIDIA mentioned on their press release, the improvements is around 2.5x faster or 3x faster. That it is more accurate than the traditional approaches. The traditional approaches are this one I mentioned from NVIDIA, but of course there are others. So with this new tool, what NVIDIA is trying to do is to add intelligence into this error correction and calibration of the systems. And the impact of this, of course, is going to be highly integrated with the MBQ link and INSYN and the quantum processor units. And basically, the benefits that you will extract from this are the detect of errors, correct in real time, and improve of the system based on these AI trained models, of course. Something very remarkable to mention here is that agentic AI agents are going to play a big role on the automated calibration and error correction, because before with the MBQ link, you had to do experimental work. It was isolated on stable systems. You had to do manual limited error correction. It was not a very scalable infrastructure. With this new technology, with the INSYN, now you have an AI driven quantum control. And of course, you can have more hybrid systems and more scalable automated infrastructure, because your workers to do this work mainly not be humans. They will be agentic AI agents. So if you understand this, then you can see how the full picture is forming, because now this will integrate to other technologies they just mentioned some weeks ago. So the main impact of this is the reduction of the coherence and noise and the elimination of the constant manual calibration and error correction. And the agentic AI agents are going to be fully deployed to do this work instead of humans being in charge of doing this. So this is from Jensen Huang, the founder of NVIDIA. He said that AI is essential to making quantum computing practical. With INSYN, AI becomes the control plane, the operating system of quantum machines, transforming fragile qubits to scalable and more reliable quantum GPU systems. So if you see this like an analogy, basically you can say that now INSYN is like the brain of the system, and the MBQ link is like the nervous system of the infrastructure, and the muscles, the bones are the quantum processor unit, if you want to make an analogy of how this looks like. So just to close up on this short tutorial, NVIDIA mentioned about the quantum processor units, how they INSYN this new intelligence at scale that is going to be integrated in the whole platform with MBQ Link and the agentic AI and the AR factories. So if you want to see how this may look like, remember that NVIDIA is working with OpenClaw. They call it NemoClaw. And basically, on the top, you are going to have these agents, these NemoClaw agents, and they will be in charge of using INSYN to do the calibration and the error correction. and then you'll have the MBQ link and the quantum hardware providers. And if you now understand this, you can clearly see the strategy they are playing, because they are not only having the AI factories for inference, but they are planting the seeds for using these AI factories and AI agents to do the calibration and error correction of quantum systems and quantum providers. So this is going to have a big impact, of course. And on the next call, I'm going to talk about another release they talk about, that is the QCalc benchmark. That is the benchmark that they propose to do performance analysis on the systems. So just to summarize, is clearly the strategy and the way NVIDIA is presenting their solution. Basically, like I mentioned, they will have the AI factories for all the inference and all the agentic AI. And basically, the agentic AI is going to be an extension for quantum computers for the calibration and error correction. So those tasks will not mainly be done by human beings, but by the agents itself. Of course, there are some human intervention, but it is going to be mainly done by the agents. And this is a game changer. And of course, the INSIN is adding this artificial intelligence into the system, like he called it the control plane, because it's going to be the brain of the whole operation of the quantum machine. And the link, of course, that is there, like I mentioned, is the nervous system of the infrastructure. So it's very good to see how the industry is moving. And you may ask yourself, what is the implication of this? So right now, in the stage that we are, most of the quantum algorithms has a hard time because the hardware cannot scale enough at the moment. But if you can fix this error and these calibrations, this is going to enable the creation of new quantum algorithms and speed up some of them that will have an impact in the whole world, and let's say in drug design, optimization, and one of the most important, security. Because Google and another company just released that maybe the quantum day, that is when a quantum algorithm can break the classical cryptography, is closer than we thought. So if you understand this advancement and the impact on the way and the new possibilities to create new algorithms and scale new systems, is going to have new solutions in the market, and again reaching quantum utility in the beginning, but at the end the goal is to go and do quantum advantage. So on the next video, I will explain about the benchmark of quantum systems, so for you to know which are the metrics that you should take care of, and you can grasp how the industry is moving on that. So see you on the next.